All right, so now that I fixed the lesson number, it is Algebra 2, Unit 5, Lesson 5. I have a copy of the notes here on rational exponents. So you might have maybe been wondering why we were doing all these lessons on radicals. So simplifying radicals, multiplying, dividing radicals, adding and subtracting radicals, and then all of a sudden, laws of exponents. Okay, but why? Why do we go radical, 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 exponent? Well, this lesson is going to connect that for you so you get this idea of why was this lesson on the laws of exponents coming in the middle of a unit on radicals. So to start off, there's an introduction activity on a calculator. Do each of the following and just note your observations. So even if you're doing this from home, pause the video, go grab a calculator, log into Desmos, and go ahead and do like 4 to the 1/2 power. And I have a note on your handout that says if you need help figuring out how to enter this into a calculator, ask a neighbor or raise your hand. And it's kind of hard to do that as like a part of the lesson because everybody's using something different for a calculator. But typically you can write in like 1 divided by 2 to get the 1/2. You could use the decimal equivalent maybe. But go ahead, do your best, and then come back and we'll kind of talk about what this activity is supposed to drive home for you. Okay, so what I hope you noticed is, first of all, you would want to do this. So 4 to the 1/2 is 2, 9 to the 1/2 is 3, 8 to the 1/3 is 2, 16 to the 1/2 is 4, and 16 to the 1/4 is 2. And this is note your observations. So some of these are going to be a little bit easier to make the connection than others, but the ones I'm going to draw your attention to are the to the 1/2. Okay, so if you take a 4 and you raise it to the 1/2 power, you get a 2. And what I'm hoping you'll notice is that raising it to the 1/2 power seems to be the same as square rooting it. Okay, so if you take 4 and you square root it, you would get a 2. If you take 4 and raise it to the 1/2, you would get a 2. Same with, let me clean that up for a second. So this would be like the square root of 4. The square root of 9 would give you 3. The square root of 16 would give you 4. And so this raising it to the 1/2 power seems to be the same thing as square rooting it. Now the other two aren't the 1/2 power, and so that makes them a little bit harder to tell what might be going on with that. But once you see the square root, that gives you an idea of where this might be going. So the 8 to the 1/3 is actually the same as the cube root of 8, and the same pattern's going to hold down here. The 4th root of 16 is 2. Now, without getting too explicit about this, what I wanted you to see in doing this activity was simply that there is a connection between the exponent and the radical. And a couple of you have asked questions in class, like, why can't we add the radicands? And the best answer I can give you until we cover all the exponent stuff is because you can't. And this lesson will make it a little bit more apparent why. Okay, so there's obviously a connection between at least the denominator of the fraction. There is a spot for the numerator of the fraction also. It's just that makes it even harder to see what's going on. So for the intro activity, we're just going to keep it to the denominator. And again, the goal is there is obviously a connection between the exponent and the radical. This is the 4th take on this slide, and I am going to get it right this time. Even if this is awful, I am keeping the recording. Okay, it is almost 4 o'clock on a Friday afternoon, so I'm very tired. So what we have here is our key idea. We have some kind of radical. So we've been in this unit on radicals. We have some value x. We raise it to the 8th power, and then we take the bth root. Now, we already explored this in the little intro activity. We know that that index seems to correspond with the denominator of the exponent. Well, it does. So this can be written as x to the a over b. So the exponent becomes the numerator and the index becomes the denominator, regardless of size. Okay, so notice it doesn't necessarily mean it has to be a proper fraction. It could be improper. Now, if it's an improper fraction, we might have some other stuff going on there, but that's not part of the definition. There's nothing about this that says anything about like a and b in the relative size. All right, now the next one down here is the same but different. So this one, we have some value x. We take the bth root, and then because of the parentheses here, the last thing we'll do is raise it to the 8th power. So notice that the order of operations is different. This one, we raise x to the power and then take the root. This one, we take the root and then raise it to the power. And it turns out that they are exactly the same. Now, that should bother you. Okay, if you're paying attention, you're alert. Unless it's self-evident that they're the same, but I don't know why it would be self-evident. Okay, all through math, you were being told order matters. You do multiplication before you do addition. You distribute before you divide. I don't know what it is, but then you've also been told that the location and size of your numbers matter. You can't write an exponent like that. Okay, that's not what an exponent looks like. And then all of a sudden, here I am telling you, oh, by the way, kiddos, it doesn't matter where the A is. You can put the A on the inside, you can put the A on the outside. Doesn't matter. It's all the same. That should kind of bug you a bit because that goes against the things that you've been told about how math works. So there, I can do a really detailed explanation of this, but I'm going to give you the short middle of a lesson explanation. It has to do with the fraction and how you can break a fraction up. Okay, so that is a divided by b. But remember that division, like there's no such thing as division. Division is multiplication by the reciprocal. So instead of a divided by b, you could write that as a times 1 over b. And I'll kind of pause for a second and I'll let you think that through. Okay, now multiplication is commutative, which means that you can switch the order here. So I could have just as easily have written 1 over b times a. This is why you get the order doesn't matter, okay, because it comes down to multiplication. In this situation, this would be like taking the exponent right there and then taking the bth root. So you take the exponent and then do the root, and the exponent would end up being under the radical. This direction, because multiplication, you can just switch the order around, you would take the root, right here, the bth root, and then raise that whole thing to an exponent, and therefore the a would end up on the outside. So really, you should think, not matter. And then there's an explanation. There's a reason why it doesn't matter. There's a reason why that ends up being like interchangeable operations there, and it has to do with the commutativity of multiplication. Now, down here, I'm actually going to make a revision to this because the and vice versa part can be debatable. It's not all the time, so I'm going to try to make that correction on the in-class PowerPoint. But every radical can be written as an exponent. And then I'm going to put a little asterisk, and it says and vice versa. I just want to be careful about that because some exponents, like if you have a whole number exponent, I guess like you could find a way to write that as a radical by changing the denominator around, like 2 could be 4 over 2. And you could figure that out, but it gets a little messy and a little sticky, okay? So I don't think I want to go too far into that. Main idea, though, is that you can go back and forth between your exponents and your radicals. It's just you can change the different notation around. You can use a radical notation or you can use an exponent notation, which is why we have a discussion of exponents in the middle of our unit on radicals. Oh, I've done this slide a bunch. Hang on, I'll see you on the next slide. All right, so we have some example problems here, and they range from like level easy to, oh, let's think about that. Okay, so the first one here has, what is the first one here? X to the 1/5. So over here on the right, okay, I am going to not do that. I am going to do something different. Okay, we're going to do the bth root of x to the a equals x to the over b. And what I'm doing there is I'm copying it down so that I have that key idea where I can see it, because this is a low level skill. This is really just about mechanically rewriting stuff from one form to another. Now, there are a couple of little catches that we might want to think about, but well, we'll take it one thing at a time. So x to the 1/5. So the directions here would be write like these two examples, 1 and 2, as a radical. And then 3, 4, and 5 are all radicals, and we're going to write them as exponents. So we'll start by writing down the radical. X is what goes under the radical. And then we just have to place the 1 and the 5, okay? The top number or numerator is the exponent. So you might write x to the first power. You don't have to write to the first power. So that goes back to our intro problem. And then our denominator will be the index. Okay, the b is going to be the index. I'm having an afternoon here. There we go. And that's all you would need to do. Next problem. We're going to write this as a radical. X is what's called the argument there, the radicand. And then it's just placement. So the numerator is the exponent. So numerator a value going to be the exponent. That'll be a 2. And then the denominator is the index. That is a low level skill. Every single person can get that right. The only reason you mess this up is because you don't practice it. That is the only reason. Nobody can say that's complicated or challenging or difficult. You just have to practice it. If you don't practice it, you end up putting them in the wrong place. And it happens every year. People will put them in the wrong place, and it's just because they didn't bother to learn it, not because it's a complicated skill. Now, 3 can be a little bit different. So I want to point out a couple things to you. The radical acts like a grouping symbol. So if you think back to your order of operations, what is our order of operations? PEMDAS. Okay. PEMDAS. And the radical here is functioning like a grouping symbol. Okay. And so if you look over here, our grouping symbol would be the P for the parentheses. So parentheses is a grouping symbol, and it just kind of makes a nice generic thing for your PEMDAS. But in reality, there's actually a lot of grouping symbols. And when you remove those other grouping symbols, you often have to replace them with parentheses to make sure that everything is still grouped. So the radical there is grouping the 7 and the x together. Now, this is a square root, which means the index is going to be a 2. That means the denominator of the exponent will be 2. And then you need to think, okay, well, if I don't see an exponent, what would that exponent be? Well, if you don't see one, it's got to be a 1. Now, if you think back to your laws of exponents, both the 7 and the x need to be raised to the 1/2. Okay, both of them have to be in the parentheses to be raised to that exponent because both of them were under the square root. If you don't have the parentheses, then the exponent would only go with the x, which would mean only the x was under the square root, and that's not what we want there. All right, here's our next one. We have C. And it's really, truly just like, let's put these things in the right spots. So the index is going to become the denominator, and the exponent would become the numerator. So in this case, that would be 2/4. Now you can actually simplify 2/4. And what that might point out to you, some of you might notice that if you were to change that back, it would change back like this into a square root. And you might notice, oh, we went from a 4th root down to a square root. That's actually a process as well called simplifying like the order of the root, and you can actually get like the index lower. It is not something that I would typically cover with you. That's a very limited application skill, but it is something that you could do with it. All right, and then our last one, we have the cube root of 5xy all to the 6th power. And so I guess that's already grouped. I guess we'll keep that nice and grouped. And we will do 5xy. The index is the denominator, and the exponent is the numerator, and 6/3 we can definitely simplify. 6/3 is squared. So if you can simplify like the fraction, absolutely you can. And I do want you to notice that there's nothing that says that it has to be a proper fraction. Okay. 1 year, and this is where student participation in class is so important, why I don't want my students just sitting there copying stuff. Like I want you to say back to me what your understanding of the material is, because 1 year, this was a long time ago, I was doing a bunch of examples on this topic, and a student said to me, okay, Ms. Taylor, so when we're putting it in fraction form, the smaller number always goes on top. Because, and then I looked back at my examples, I said I had 1/5, 2/5, 1/2, 2/4, and I think my other example was like a 3/6 or something. And so the student was making this observation and was making this connection because of the examples that I had put up there, and it wasn't the right connection. So, and because he said that, what I did was I made sure I went back into my notes and I changed up my examples a little bit more, so that I wasn't going to accidentally, and it was purely by accident, pick examples that all work the same way. And so as a teacher, I try to make sure that the examples I show you are going to be a little bit varied. So, we have one where we had to know the exponent was a 1. We had one where we could simplify it. And then this one was intentionally to make sure that you saw one that had that improper fraction, because it's easy to make those connections. And I'm really thankful for that student for saying something about it, because that's the kind of thing that makes me a better teacher. And I always want to become a better teacher. So that brings us to some practice problems. If you are doing this at home, take a moment, pause the video, and all you're doing is rewriting them. So there is limited, if any, work to do. And then unpause the video when you are done, and we'll take a moment and talk about them. Okay, hopefully you pause the video. So for the first one, writing it as a radical, your radicand would be a 36. Your exponent would be a 1, and your index is a 2. And you could just write that as a regular old square root of 36. You do not need to put the index or the exponent. Both of those are implied. Next one, we have the radical. The radicand is t. The exponent would be the 3, and the index is the 4. So the 4th root of t to the 3rd. Next one, this one's got that exponent on the outside, so it goes back to that previous slide where we talked about how that doesn't actually matter. So for this one, now we do need to make sure that we're keeping this grouped though. That's an easy thing to miss, that you've got that 2x and it's under the radical and the radical is grouping it. But as soon as you get rid of the radical, you've got to find another way to group it. So we got to make sure we put that in parentheses. The numerator will be the 2. The denominator would be the 3. So 2x to the 2/3. And for the last one, we have the same deal here with the xy. Make sure that that stays grouped together. The exponent on that would be a 1, and the index is a 2. So we would have xy to the 1/2. Now, what I tell people when it comes to rational exponents is, I mean, like, you want to remember this, but we talk about reality. What are you going to need to know after you're done with the unit where you study this? So the unit where you study this, we go into all kinds of detail and everything. After this unit, what are you going to see? If you only remember one thing, I want you to remember that a square root is the same as an exponent of 1/2. That you will use in future math classes, particularly those of you that go to calculus. There are some things that you can do in calculus that are awful to do with a radical, and what you will do is you will take all of your radicals and you will change them over to exponents so that you can work with them better. And that's going to be the most common radical that you have, would be the square root. So if there's one thing you're going to forget everything after this unit, the one thing I really want you to hang on to about rational exponents is that one. All right. So what can this information do for us? Why is this a tool that we want in our mathematical toolkit of things we know how to do? Well, there it is. As radicals, we cannot do the problem on the left there. We have the 4th root of 6 times the cube root of 6. And we can't do that if the indices don't match. Indices is the plural of index, okay? Just so you know what that is. So the indices don't match. So you've got a 4th root and you have a cube root and you're stuck. But if we change them to exponents, we can use the laws of exponents to work the problem further. Hence why we study laws of exponents in this unit. So in this first one, this would be 6, and then the exponent on the 6 is 1, and the index is 4. And this one, again, the exponent on the 6 is 1, and the index is 3. So that transfers over as 6 to the 1/2 times 6 to the 1/3. Now, if you think about your laws of exponents, when you are multiplying like bases, you can just add the exponents. Now, I am aware that this might get a little touchy for some people because even though fractions are covered in elementary school, covering them and knowing them and comfortable working with them are not the same thing. So I believe Desmos does do this. You can go into Desmos and just do 1/4 plus 1/3. Make sure the answer is a fraction. You'll be good to go and you can get that. If you want to do it out by hand, here's what it looks like. Okay, to add fractions, we need a like denominator. So we are going to use that fact that we were using a couple of sections ago. And you're going to multiply by the number 1. So 3 over 3 is 1. I'm going to take that 1/4 and multiply it by a 1. I am also going to take the 1/3 and multiply it by a 1 because 4 over 4 is 1. Now, why did I pick 3 over 3 and 4 over 4? I picked them because I knew that they would give me my common denominators. So multiplying this first piece, 3 over 3 times 1 over 4. 3 times 3 is 1. 3 times 4 is 12. And so I get 3 over 12. And then doing the same thing right here. 1 times 4 is 4. 3 times 4 is 12. And so all you're really doing there, and then 3 twelfths plus 4 twelfths is 7 twelfths. And we actually have an answer. So we were able to multiply them. Now, you might be saying, well, how did you know to pick that? Practice, and that goes back to some of your more elementary school stuff, like how do you find a common denominator? You're looking for the least common multiple. What do you multiply by? That's not in the scope of Algebra 2 to go over that. If you would like to go over that, I can make a video just on that. I am going out to get something for supper. This is just continue on my phone. All right. Good to know. So anyway, I can make a video of that and go into that, or you can use your calculator or use Desmos to do that work for you. Now, technically, this is done, so we have found a way to carry out the multiplication. Some people might want to change it back to a radical. I'm going to keep that step optional for you. So the 12th root of 7. Now, at this point, I do get students who try to draw like a shortcut, and they say, well, I can just multiply the two indices to get the new index and then add the indices, and that will give me the new exponent on the 6. That'll work as long as you don't have other exponents in play. I hesitate to say like, oh, is it going to work? If we have x squared, that's going to change off, that pattern there. So I'm happy to explore that further. I've never had a student ask me to explore that further, and I've never been interested enough to do it myself. But I can if it is something that interests you. So that's one of the things we can do with this. Last little topic here. What about decimal exponents? So these you're likely to see in science classes. So you're likely to see exponents that are decimals, and you might at first think, well, how can something be multiplied as a factor 1.2 times? How do you do that? It kind of comes from the same place as our exponent of 0 or our negative exponents. But there is a way to do this and to kind of make some other sense out of it. And pretty much all we're doing here is rewriting it. We're looking at different ways to represent x to the 1.2 power. So the way I do it, I'm going to present this the way that I do it, the way I go through in my head and reason it out. That may or may not be the best way for you. So if you want me to do this a different way, I'd be more than happy to do that. 1.2 is 1 2/10. So what I did there is I just set it like the proper way. So 1.2, a lot of us say 1.2, which is fine. But that is 1 and then the 2 in this position right here, this is the 10th spot. Okay, so if you were looking at this and it had a dollar sign, you would know you had 2 dimes because it would be 20 cents. So dimes are 10 cents. So 1.2 is 1 2/10. So what I do is I envision that as a mixed number. How would you write 1 2/10 as a mixed number? Well, like that. Now, most of you know I'm not really a fan of mixed numbers. They are used in cooking and nowhere else as far as gas prices. You see them in gas prices. But it does give us a way to go from the decimal form into a fractional form. Now, we don't want a mixed number over there as our exponent. So we're going to convert that to an improper fraction. And I have the steps up there. This is one of those things, I don't actually know how long ago you would have done this, but it's one of those things you do in elementary school. And it's convert to an improper fraction. And there's a method for this. And again, why this works, like why this process works, is not an algebra 2 concept. But if you'd like me to go into more detail about the process and why it works, that I would be happy to do for you. So you multiply the denominator by the whole number. So in this case, we would do 1 times 10, or 10 times 1. So you multiply these two, and then you add the numerator. So 10 times 1 is 10. 10 plus 2 is 12. And that is the new numerator. And then you keep the denominator. If you do not believe me or you're not sure, you can grab your calculator and do 12 divided by 10, and it will tell you 1.2. Now, you can simplify that, okay? So this does simplify because they both divide by 2. You can simplify that to 6/5. If you're not sure, grab your calculator and do 6. Oh, that's a program. 6 divided by 5, and it'll say 1.2. Okay, so it'll confirm that for you. So this would be 6/5, and depending on what you're trying to do in your problem, maybe that's all you want to do. Maybe you want to write it as a radical, so that would be that's called not committing to what your number you're writing down, the 5th root of x to the 6th power. Some people have done this and they noticed, oh, Miss Taylor, you can simplify that because this would be x times x times x times x times x times x, and we're looking for a group of 5. So the fifth root of x to the fifth is x, and then they'll have that one x that's still under there. So depending on what you were asked to do in a problem, you can do a whole bunch of things. And like a great multiple choice question for something like this that I could put on your at-home test, which I have not written at the time of this recording, so don't ask. But is to like have 4 multiple choices and say which one of these is not equivalent. And you could have answer choice A is x to the 1.2, answer choice B is x to the 6/5, answer choice C is x, fifth root x, and answer choice D is something else, like not the same. Okay, and you would have to figure out which one of these is an equivalent. Now, in terms of like actual application in a math or a science class, you would not need to do all these things. This is like the math class where you're learning the raw skill of like being able to go back and forth and understanding the different forms it can take. And then how you apply it is going to be in a different class. But you'll be ready for it when you see it. That brings us to our last few practice problems. So take a minute, pause the video, and then when you have had a chance to do the practice problems, unpause them, and we will go over them together. All right, for that first one, this would be 5 to the 1/2 times 5 to the 1/5. And so to multiply those, we would add those fractions. And I'll go ahead and I'll do that scratch work over here. So we end up with 5/10 and 2/10. So we will get 7/10. Okay. Oh, wait a minute. I skipped like a step that I should have written. So 5 to the 7/10. And then if it asks you for the radical form, you can put it in the radical form. But either of those is generally okay. That's a read the directions and make sure that you're leaving the answer in the right form. For 2.3 over here, that is 2 and 3/10. So 10 times 2 is 20. 20 plus 3 is 23. Keep the denominator. If you're not sure if you've done that correctly, go ahead, grab your calculator, do 23 divided by 10, make sure that you get the 2.3. So that means you've got y to the 23/10, or y to the 23 power 10th rooted. Now, this is one where you can tell it can be simplified, but where you probably don't want to write out y times y times y times y times y like 23 times. But you know you're going to be looking for groups of 10. I'm just going to say 10 y's, then 10 more y's, and you would have 3 left over. So that would be y squared, the 10th root of y to the 10th. I should probably change that. I just don't want you to think that's multiplication. So, okay, so you'd have 10 y's, 10 more y's, and then you'd have those straggling 3. So 10th root of y to the 10th is y. We're going to do that twice, and we're left with y times y times y. Again, whether you're supposed to leave it like this or simplify it, read the directions. Don't ever do more work than you need to do, especially on a test, but make sure that you carry the problem out to completion as far as you can. So that completes our lesson on rational exponents, and you know where to find me if you have questions.